Hey guys, it's been a very unusual March break, but let's take a shot at doing a lesson here together. I'm pretty new to this, so there might be some little bumps in the road as we go along, but for now, this is how we're going to proceed. Just be aware that all the lessons that we're doing right now are optional, so you don't have to do them if you're not. You don't feel like you're okay to do them right now. If you're worried about stuff, that's fine. But if you do want to follow along, that's great. We're gonna keep going with doing some curricular stuff here. Keep going through our chemistry book. So if you've got your chemistry notes with you, you're going to need them, and you'll also need access to a periodic table. I think I'm going to break this video up into a few sections. The first part is going to be like a little bit of a review. Then I'm going to get you to do some additional practice questions. I'm going to come back and take up those questions. And then I'm going to give you a second little set of practice questions, and I'm going to get you to take those up. And when you're done, there is a short little reading from the textbook I'll mention at the end of the last video. And finally, when you're done all that, there is a little exit ticket quiz. The quiz is, again, optional. It's just there for you to test your own knowledge and see how you're doing with this lesson. And tomorrow I should be online to answer any questions you might have. I'm going to try and do a Google Meet. And I should be online at around 1 p.m. That's 1 p.m. on Wednesday. So anyway, let's give this a shot. I'll try and go at a reasonable pace here. Hopefully I'm not going too slow, just due to nerves. Okay. So when we left off, we were talking about ionic bonding. And so at the end of this lesson, it should be comfortable for you to be writing the name and writing the formula for any simple binary ionic compound. By simple ionic compound, I mean simply just a regular old metal like magnesium and a regular old non-metal like chlorine. And you should be able to write the formula for this at the end. That's what the formula looks like for that. And you should be able to name that formula too. The name of this formula right here is magnesium chloride. And by the end of this, you should be able to do that, no problem. The textbook portion also talks a little bit more about the properties of these ionic compounds. So what are they like when you interact with them in the real world? So, okay, without further ado, let's do a quick little review of what we were talking about before you left for the break. So we were discussing ionic bonding. We talked about how in order to get an ionic bond, you need a metal and a non-metal. The metal is going to give away its electrons and become positive, and the non-metal is going to accept electrons and become a negative ion. So, for example, we've got sodium and fluorine here. Sodium is in group 1, so it's going to have 1 valence electron. Fluorine is in group 17, so it's going to have 7. And then in order for this thing to become stable, it's going to have to, sodium is going to have to give away its valence electron to fluorine. So fluorine is going to accept it, and then sodium is going to become a positive ion. It's going to have a 1 plus charge because it gave away 1 negative electron, and fluorine is going to become a negative ion because it's going to accept a negative electron, and now it's a negatively charged particle. Because they have opposite electrostatic charges, these two things are now going to be pushed towards each other. That's way back from grade 9. Law of electric charges, opposite charges attract. So we got opposite charged atoms here, and they are going to attract each other. So there's this can happen between anything that wants to give away electrons, generally those are metals, and anything that wants to take electrons, which are generally nonmetals. So yeah, you were probably, I think we did this before the break. So if you, for example, want to see how this is going to bond, this is sodium chloride, you know that there's going to be one sodium because you look at the subscript right here. Oh, it's a little bit too big. You look at the subscript, there is no subscript, so if it's nothing there, that means that there's only one of them. So there's only one sodium atom in this, and then chlorine also has no subscript. So that means there's only going to be one chlorine. Sodium has one valence electron because it's in group 1. And chlorine has 7 valence electrons because it's in group 17. And we're going to get an exchange happening right here. And we're going to end up with sodium becoming positively charged ion and chlorine becoming a negatively charged ion. And then collectively, these two are going to attract each other, and then they're going to become sodium chloride. So we talked a little bit about the naming conventions before you left. This idea that when it's just a simple ionic compound with a metal and a nonmetal and a regular old metal and a regular old nonmetal, you just name that the name of the metal ion, in this case is sodium, and the name of the nonmetal ion, which is chloride. All the nonmetal ions are going to be named I. They're going to end in IDE. Okay, so that's the basics right there. And then at the end here, we're going to have something that has one positive ion in it and one negative ion. So we're talking about how many atoms here have become positive. There's one positive atom at the end, and there's one negative atom at the end. And so there's one positive ion at the end and one negative ion at the end. An ion is just a charged atom, an atom with a charge. Okay, so we did a bunch of examples of this. And we also looked at this idea of, well, what if there's more than one of a metal or a non-metal? So for example, here, the magnesium, there's only one, but the chlorine has 2. So again, let's just name this one simply. You're just going to call this magnesium chloride. But when you're building it, this time there's going to be one magnesium because the no subscript, but there's going to be 2 chlorines because there's a subscript of 2. So magnesium has 2 electrons because it's in group 2. Chlorine has 1, 2, 3, 4, 5, 6, 7 because it's in group 17. 1, 2, 3, 4, 5, 6, 7. And then in order to get them to bond, magnesium's got to give away all of its valence electrons because it's a metal. And chlorine is going to accept 1 electron from each. And we're going to end up with a positively charged magnesium in this bond. In this case, it lost 2 electrons, so its charge is going to become 2+. And we've got chlorine that has gained each 1 electron. So each one is going to get a charge of 1+. And if we look at the number of positive ions, that is positive atoms, in this bond at the end, there is 1 positive atom. That is the magnesium. So there's 1 positive ion, and there's going to be 2 negative atoms here, 2 negative ions. And so then there are 2 negative ions. Okay, I'm going to do one more of these really quick. I'll do a little bit more complicated one. Why don't we do this one right here? So this is Be3N2. And we're just going to name the ions. So the metal is called beryllium. And the nonmetal is called nitride. Becomes ide when it becomes an ion and takes those negative electrons. So in order to make this one, we got to look at their subscripts here. There's a 3 subscript for the beryllium and a 2 for the nitrogen. So we need 3 berylliums, 1, 2, 3, and we need 2 nitrogens. Oh, I'll keep them color coded here. 1, 2, 1, 2. Oh, hold on a second. Where's beryllium? beryllium is in group 2. Yeah, so it's got 2 valence electrons. And nitrogen is in group 15. So it's got 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so this beryllium is going to give away 1 here and 1 here. So we've got 1 there, 1 there. And then there's 1 missing here from this nitrogen, which it's going to take from the next beryllium. And then this beryllium still has to give away 1, so it's going to give it away to this nitrogen. And then 1 there, 1 there. Okay, so in order for this to be stable, all the berylliums, the metals, have to give away all of their electrons, and the nitrogens had to fill all of their empty spaces. So there's only one way to make this possible, and that's if you have the right number of each of them. If you only had 1 beryllium and 1 nitrogen, the beryllium would give away its 2, the nitrogen would take 2, but the nitrogen would still need an extra electron, so it wouldn't be stable then. And if we were to have 2 berylliums, then okay, then the nitrogen would be satisfied, but then this beryllium down here would still need to get rid of an electron. So in order to make this bond work, you have to have the right number of the metals and the nonmetals. So this ratio between the two of them, 3 berylliums and 2 nitrogens, is the only ratio that'll actually allow them to be happy with each other. So we need to have, draw my ions out here. So each beryllium is going to give away 2. So that means beryllium is going to become 2 plus. And there's 3 of them. And each nitrogen is going to gain 3. So our nitrogens are going to be 3 minus. And if you look at the total charge here, you'll notice that the total charge here for the positives is 6 plus, and the total charges here for the negatives is 6 minus. And so that's key, is that these charges always have to totally counteract one another. You have to have a total charge of 0. So 6 plus and 6 minus is going to give you a charge of 0. And if we go back and look at our previous bonds, you can see that that happens every single time. So for example, back here when we did this one, here on our positive side we have 2 plus, and here on our negative side we have 2 minus. So the positive charges here are going to counteract the negative charges, and we have a total charge of 0. And the same thing is true of even the simple one up here, which is that we have 1 plus and 1 minus. Plus 1 and minus 1. That's going to give you 0. So you get a total charge of 0 in each case here. Here we had 3 positive ions. Better fill my table here. 3 positive ions and 2 negative ions, but a total charge of 0. That's the key. So an easy way to figure out then, if you know that you have to combine 2 things together, is to just look at their charges. Because if you have, for example, a charge of -3, what that means is that in order to so what was I going to say here? Oh yes. So if we want to figure out how many there are that are necessary of each of these, all you have to do is look at their charges. So for example, we want, let me write them down like this. So we've got beryllium, 2 plus, and we've got nitrogen, 3 minus. In order to get a total here of 0, I would have to have 3 of these, and I would have to have 2 of these. So you'll notice that it's the same as the charge of the other ion. In other words, you could just bring this 2 down here, and you could just bring this 3 down here, and that gives you Be3 and 2, which is the only combination of these 2 that actually allows them to work together. So let's do another example of those so you can see what that looks like again. Let me do it here with the beryllium. So this is beryllium bromide. And let's build it again. So let's look at the subscripts here. We've got 1 here and 2 here. So I've got beryllium, and there's only 1, and bromine. There's 2. So beryllium is in group 2, and bromine is in group 17. So there's going to be 7. And we're going to have an exchange of electrons here. So 1 is going to go here, and then that bromine is satisfied, and this one's going to go here, and this bromine is satisfied. Then we're going to end up here with a beryllium with a charge of, it's given away 2 electrons, so it's going to become 2 plus. And we've got 2 bromines here. And each of them takes 1 electron, so they're going to have a charge of 1 minus. And if we take our totals at the bottom, we'll notice that we've got 2 plus total charge and 2 negative total charge. In other words, it adds up to 0. So if I look at just their charges, so I write the beryllium out. There's 2 berylliums, and I write the bromine out. There's the charge of 2 plus, and I write the bromine's charge out. Bromine is a 1 minus charge. The number of bromines that I need in order to counteract this charge of 2 plus is 2. And the number of berylliums that I need to counteract this charge of 1 minus is 1. In other words, I've just taken the numbers that are up here and I've just brought them down here. So in order to get the formula for this, is just going to be BE1, which you don't write, so you don't need to write anything there for 1, and then BR2. So that taking the charges and moving them down in order to figure out how many you need of each in order to make a stable bond, we call that the crisscross rule. Okay, so I'm going to just write that in right here. This is the crisscross, or at least I call it the crisscross rule. I think that's a generally accepted term. I think it's called that in your textbook as well. So we can use that crisscross rule to figure it out. I'm going to show you some examples of us doing that together. I'm assuming everybody is okay with this. I think we took this up before the break. So I'm not going to go into too much more detail here on how to show metals bonding with nonmetals. We called that a Lewis dot bonding diagram. It's also called an electron dot diagram, a bonding diagram. And you can use that just to show how a metal is going to bond with a nonmetal in an ionic bond. So we can come back to those diagrams later when we talk about different types of ionic bonds. I'm gonna leave these here. What I'm going to do right now is just go through the procedure here for naming, which is fairly straightforward. And then I'm going to go through the procedure here for figuring out the formula. So that's using the crisscross rule. So that is, if I were to see this formula, what would I call it? So how do I name it? And if I were to see this name, how would I write it? So if we want to go in the opposite direction, we have a name, and now I got to figure, okay, how am I going to write beryllium nitride? Okay, then we're going to use the crisscross rule, and we're going to use that to figure out this. So we got to be able to go in both directions. If somebody gives you a formula, you got to be able to name it. And if somebody gives you a name, you got to be able to write the formula for it. So I'm going to go down. I'm going to do a few of these examples together. I think one of the classes we started this before the break, but I'm going to do a few examples together, and then I'm going to do a few examples of these going in the opposite direction from name to formula, using the crisscross rule. And then I'm going to end the video, and then I'm going to post a second video just taking up some of those questions after you've had an opportunity to try them out for yourself. Okay, so let me do a few of these here. Again, these are very straightforward. We're going to name them by just naming the ions. So this is metal. The name doesn't change. It's just sodium. And the non-metal bromine here is just going to end in ide, I-D-E at the end. So if you add I to the end of this one, that's pretty much all there is for the naming. So sodium and bromine put together, this is going to become sodium bromide. Notice, by the way, that I don't capitalize this. We don't capitalize these, and in general, it's a nomenclature and naming rule that you don't capitalize. So leave your capitals off. So this is sodium bromide. Now, if we want to figure out the formula, that is how to write sodium bromide, it's not just going to necessarily just be one sodium and one bromine. You could go back and you could write out and do the Lewis dot diagram or the electron dot diagram for sodium bromide, but that's time consuming. We don't want to do that, so we're going to do a shortcut. So all we have to do here is to write out the ions for each. So the ion for sodium is it's in group 1. It's going to give away 1 electron, so it's going to become +1. And bromine is a negative ion. It's a nonmetal. It's going to take 1 electron in group 17 and become -1. Hopefully, at this point, you've looked at your ion periodic table that we created before the break, and you can figure out what the ionic charge is going to be of a given metal or nonmetal just based on what group it's in. So if you can do that, if you know what group it's in, and you can just do that, this is pretty easy. Then all you need to do then is take the number that's up here, so it would be a 1 for sodium, and you're going to bring the 1 down here. And there's a 1 up here for bromine, and you're going to bring the 1 down here. So this is sodium 1, and then bromine 1, or just NaBr. Okay, well that's a simple one. Let's do one that's a little bit more complicated than that. So magnesium is a metal, and bromine is a nonmetal. It's always going to be metal and a nonmetal here in an ionic compound. And so magnesium, just name stays the same, magnesium. And then bromine is going to become bromide. And if we want to write the formula for these, we're going to have to look at the charges. So the charge for magnesium is in group 2, so it's going to become 2+. And bromine, we already did bromine, it's in group 17, it's going to become 1-. So we're going to take the 2, and we're going to bring it down here, and we're going to take the 1, and we're going to bring it down here, and this is going to end up being Mg. Oh, change our color up here. This is going to be Mg1 because we brought the 1 down, and then Br2. So if you do this, if you follow this crisscross rule, you're always going to end up making sure that the total charge is going to be 0. You'll have the right number of the metals and the nonmetals to make the total charge 0. So that's what we were trying to do here, is we're always trying to figure out what is the total charge. How do you make the total charge 0? Here it's 0. So if you have the right number of each of these, your total charge is always going to be 0. Okay, I'm going to do one more here. This is a tricky one because this requires a little bit of additional thought. So magnesium and sulfur, you put them together. Again, you just name the ions. It's pretty straightforward. This is just going to be magnesium sulfide. And then, if you want to write the formula for magnesium sulfide, group 2, magnesium is in group 2, so it's going to become 2+. Sulfur is in group 16, so it's going to become 2-, because it's going to take 2 electrons. So now if you bring the 2 down here and the 2 down here, you might think, okay, well, that's going to be Mg2S2. But there's a problem with that, and that is that if you have a 2+ and you have a 2-, you don't need 2 of each of them in order to get a charge of 0. You only actually need 1 of each of them in order to get a charge of 0, because 2+ and 2-, that already cancels each other out. You need 1 and 1. So here you can actually just drop the 2's. So you would just write this as Mg. So the trick here then is that if you ever see that this is, you get to kind of think of it as a fraction. It's a ratio. So if the ratio of 2 to 2, that's the same as a ratio of 1 to 1. So if there's ever a ratio that you can reduce in an ionic compound, and this only works for ionic compounds, But if there's ever a ratio that you can reduce, then you do the reduction. So this just becomes MGS. So for example, if this was like 4, this isn't correct by the way for magnesium, but if this was like 4 and 4 and 2, okay, let's use 4 and 2 as an example. Well, that's the same thing as 2 and 1 in terms of ratios. So then you would reduce again. That would be your final thing would be 2 and 1. You don't write 1, so it would just look like this. Okay, so you have to think of the numbers of each element here as being a ratio between the two of them in the solid that you get at the end. And that's what it is. It's just a ratio between two of them that gets repeated over and over again. So if you can reduce the ratio, then you have to reduce it. 2 and 2 is the same as 1 and 1. Okay, so I'm going to give you guys an opportunity to try this. So this is just writing out the formula and name for each of these. And then below here, this is just taking the name and then going in the other direction. So I'll do a couple here just real quick so you can see what it looks like, and then I want you to give them a shot. So boron and iodide. Boron, iodide. Okay, well, boron iodide is going to have boron in it. Boron's just B. And iodide is going to be iodine. Okay, boron is in group 13. So this is going to be a 3+ ion. And iodine is in group 17, so it's going to be a 1- ion. And then in order to figure out the formula, again, we're going to think about how many we need of each in order to get to a total of 0. So in order to get to a total of 0 here, I would need 1 boron, and I would need 3 iodines to get to 0. So I have 3+, I need 3-, so I would need 3 iodines. So that you could write that, so then you could just right away just write Bi3. But if you want to, again, use the crisscross rule, which is just basically a shortcut to get the same thing, it means you're going to take the 3 and bring it down here, and you're going to take the 1 and bring it down here. So this is going to be B1I3, which is, again, exactly the same thing, B1I3. Okay, let's do one more, calcium phosphide. So calcium phosphide has calcium in it. Calcium's in group 2, so it's going to become 2+. And phosphorus is in group... I gotta think about this one a second. Just look at my periodic table here for a second. Oh, that's not a periodic table. Where is it? There we go. Phosphorus, group 15. Okay, so it's going to have 5 valence electrons, which means it needs to gain 1, 2, 3, which means it's going to get a charge of 3-. Okay, so if you just wanted to think about it, how many you'd need of each in order to get a charge of 0, well, the only combination of the two you could have would be if you had 3 calciums and you had 2 phosphoruses. That would give you, 3 calciums would give you a charge of 6+, and 2 phosphoruses would give you a charge of 6-. So you could do that math and you could figure that out if you wanted to, or you could take a shortcut and you could just do the crisscross rule. You can bring the 3 down here and the 2 down here. It's going to give you the exact same answer. And then it's going to tell you that there is going to be 3 calciums and there's going to be 2 phosphoruses. Okay, I'm going to give you guys an opportunity to try that right now. I'm going to end this video, and then I'm going to come back, take up a few of these. We're going to briefly talk about the homework, and then there's a little exit quiz that you can do at the end. Again, it's not summative, it's not for a mark or anything, but it's just to help check your knowledge at the end. Okay, see you guys in a little bit.